Okay, a second term of a geometric sequence is 6, and the fourth term is 24. It says all terms are positive, which tells us that our common ratio is not negative. Right? It's not flipping between positive and negative, which is important for us to know. It means that we might get more than one answer for R because we need to find our first term and the common ratio. We're missing two things, the common ratio and the first term, which means we're probably going to need two pieces of information. We are given two pieces of information to make those two equations, but if that's not a connection you made right away, that's totally fine. Another thing you can do is just write out the things that you have and make sure you write out formulas if you have formulas for those things, right? A term of a sequence we have a formula for. If the second term is 6 and we have the formula that it's u sub 1 times r to the n minus 1, which is 2 minus 1, so that's to the first power. Awesome. So I have 6 equals u sub 1 times r. Okay. And then the fourth term, u sub 4, is 24. Okay, well, that's still u sub 1 times r to the 4 minus 1, which is 3. I have two separate equations using these two different variables, and I can now solve for those two different variables. It's a system of equations, but we can't use a system of equations in our calculator because we've got a variable being cubed. So if it's not linear, it won't work. We have to do some of this at least by hand. Remember, by solving for this by hand, you need to isolate for one of the variables and plug in for another one. In other words, we're going to isolate for the thing that's easiest to isolate for. And if I'm looking ahead, if I'm like a chess player trying to think about things a couple steps ahead of time, sorry, that was my phone, I would not want to isolate for r cubed. I would much rather isolate both of these for u sub 1. So if I do u sub 1 equals 6 over r, u sub 1 equals 24 over r cubed. Okay, so now I have 6 over r equals 24 over r cubed. And we can go ahead and get an answer by using numerical solve. Go ahead and tell me what r is. R is 2. Fantastic. And if I wanted to know what u sub 1 is, I can plug 2 back into either this equation or this equation. Doesn't matter, but this one's easier. So u sub 1 is 6 divided by 2, which is 3. Now, this is not the only way you could have solved this. Maybe you were thinking about trying to find a different way to represent this. This is all being represented formulaically, right? We are only doing formulas. We're only looking at this in a numerical way. If you were stuck and you wanted to try to represent this in a little bit more of a visual way, maybe what you could do is write a list of numbers to see where are these numbers interacting with each other, right? Okay, well, first term, second term, third term, fourth term, fifth term, sixth term, right? We've got boom, 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 boom. This is our n, and then this will be our u sub n, right? Our first term, we don't know, but we do know that our second term is 6. We don't know what our third term is, but our fourth term is 24. And I think we've talked about this in the past where, okay, you know you're multiplying by the same number to get there, right? And this is a part of the problem solving process. If you got stuck and you didn't know what to do, writing out this thing visually and saying, okay, like I know I visually need to make this number jump here and then jump here by multiplying by the same number. You might notice 6 times 4 would get us to 24. So what if I divided that by 2? 6 times 2, 12. 12 times 2, 24. That totally works. R is 2. And then you can always go backwards and say, okay, divide by 2. That would be 3. Right? You don't have to do it formulaically. Formulaically is just one perspective that we can apply to a mathematical problem. Don't forget you have a bunch of other perspectives that you can bring in when you're trying to problem solve. Just because you don't understand it one perspective doesn't mean you can't understand it a different perspective. Try and use these tools to help unlock a problem. It then says to find the sum of the first 10 terms, which is pretty straightforward. If this was a IB problem and we got stuck on part A, we could always make up an R and a U sub 1 to then do this part at least and get those points. So we know that we have to do U sub 1 times R to the n minus 1 over R minus 1. And I know that n is actually just 10 in this case. So I just went back and filled that in right away. And U sub 1 is 3, R is 2. Cool. That feels really small for me, right? Plan, solve, assess. That feels really small for me, except for when I notice that a common ratio of 2 is not super big, right? Compared to all the common ratios that we've had in the past, right? R2 is one of the smaller common ratios we've been dealing with so far, and that we start with a pretty small number. We start with 3, right? So it's not going to get big very quickly. And 10 terms, right? If we think about this, okay, that would be 48, that would be 96. We would be getting up to like maybe in the hundreds, but not into the thousands. So it makes sense that the sum of all of them would be in the thousands. It makes sense. Okay, cool. At first it felt a little off, but now that I'm thinking about it, I'm assessing it. No, that seems right. Cool. Last problem, example 8. This is more of a challenging IB level problem where it's saying, okay, we've got a ball, it's bouncing, and it becomes 80% of its previous height every bounce. 80%. It becomes a percentage every single time this happens. That's a geometric sequence. Okay. Find the total vertical distance traveled down and up. So as it's going down and going back up and then going back down, what's the height? What's the total bouncing up and down by the ball when it's thrown from a height of 3 meters and after it bounces for the 10th time? So after it's been bounced, after the 10th, but before the 11th. It says ignore friction and air resistance. Why is it saying this? It's for all the nitpicky people out there who are like, well, technically it would. No, we're just ignoring those things. That's okay. All right. I might go in here and say, okay, R is 0.8, right? It becomes 80%. It's not reduced by 80%. It's not increasing by 80%. It's just that it is 80% every time, which if I pause and think about that, a ball bouncing, right, it would still be kind of close to what it was before, but just a little bit less. So being 80% as our common ratio makes sense. U sub 1. U sub 1, I think, is 3, right? Although it's dropped from a height of 3, and if U sub 1 means the first bounce, then maybe it's U sub 0. I don't know. Okay, I'm going to try and shift my perspective because I'm trying to push it through formulaically, and now I'm like, I think this, like the hands that Megan's doing, like maybe I just need to like kind of visualize it for a second. Maybe I like actually try and visualize a ball being dropped and like try and think about the path that's going through, or maybe I'm going to try and draw a picture of the situation. Well, it starts at a height of 3, and from there it bounces. Okay, and each height is 80% of what it was before. So that would be 3 times 0.8. This would be 3 times 0.8 times 0.8, so 0.8 squared. It's starting to feel a little bit more like a geometric sequence. 3 times 0.8 cubed, 3 times 0.8 to the 4th power. Okay, and that keeps going, right? So after the first bounce, but before the second bounce, of 1. So for each of these individual terms, I know that the exponent that I'm raising it to is 1 less than the n value, right? That if it was u sub 2, that would result in a 1. So this is really like u sub 2 in my mind, kind of. I'm just trying to make connections to the formula now and the picture, trying to see the equation and how it makes sense with here. That I like that 3 is my u sub 1. And okay, so then this would be u sub 2, and this would be u sub 3. And that u sub 2 is really after the first bounce, but before the third bounce. And u sub 3 is after the second bounce, but before the fourth bounce. Okay. Okay, so I'm going to have to keep that in mind when I start finding some formulas here. I also need to keep in mind that it's traveled down and up. Down and up for all of them except for the first height. The first height, it only goes down and then down, or up, down, up, down, up, down, right? So this is actually times 2, right? It goes up this distance and then down this distance, up this distance and then down this distance. Okay, so if I were to try and piece this together by brute forcing my way through, by just adding all of these distances, it would be 3 plus 2 times 3 times 0.8 to the first power plus 2 times 3 times 0.8 to the second power plus 2 times 3 times 0.8 to the third power. Okay, so that would keep going. And this is my second term and third term, fourth term, and those are all multiplied by 2. But if I wanted to like find the sum of those terms, the first term is not multiplied by 2. Okay. So if I were to find the sum of terms, right? I'm getting an idea. I know what my R is. I know what my use of 1 is. And I know that I'm going to be multiplying all of these terms by 2, except for the first one. What if I found the sum of all of those terms and then multiplied them by 2, but then I subtracted out one of the things that I multiplied by 2 by? I'll rephrase that. I want to find the sum of all of my terms. And because it looks like all of my terms, almost all of my terms, are multiplied by 2, what if I just find the sum of all of the terms, multiply that sum by 2, right? Taking out that greatest common factor of 2 to multiply by 2. But because I multiplied 3 by 2, but I don't actually want to multiply 3 by 2, if I counted 3 as part of this sum, I would just subtract out that 3 again, just to make sure that I haven't counted it twice. This is just one way you could solve it. I'm just trying to show you like how you could problem solve things out by connecting all of these things together. Okay. Now, the number of the sum that I'm doing. Now I have to be careful about my notation. U sub 2 is after the first bounce. U sub 3 is after the second bounce. So if I want to know the distance that it's traveled after the 10th bounce, I would actually have to do S sub 11 because 2 is after the first bounce. 3 is after the second bounce. If I want after the 10th bounce, 11 would be after the 10th bounce, but before the 11th bounce. Okay. Okay. But now I've got an idea that I can follow through with, that I think it's pretty solid. And I've written down a lot of work. Hopefully, if I get this wrong, I can at least get some method marks here because I've been showing a lot of interesting relationships. So S sub 11, 2 times that, would be U sub 1, which is 3, times R, 0.8, to the nth power, which is 11 in this case, minus 1, all over R, minus 1. And then I'm just going to subtract out that extra 3 that I got by multiplying it by 2 when I didn't need to multiply it by 2. Okay. So I'm going to go ahead and put that in there. I'm going to maybe put everything into a fraction first. Put a 2 in front and then times 3 parentheses 0.8 to the 11th power minus 1 outside of that exponent, and then 0.8 minus 1, and then minus 3. I could just type it exactly as I see it on my page, and I get 24.4 units of measurement, meters. Cool. What perfect timing for me to go ahead and end the video. I hope that you got to take away some problem solving abilities as well as learning about series. Make sure that you're just always trying to think about how am I going to unlock this problem? What is Megan doing to unlock this problem, to show how someone would unlock this problem? Write down values that you need, draw pictures, try and brute force your way through it to see the pattern, to try and unlock the pattern. Great job.